Okay, so, guys, in a lot of ways, first of all, good afternoon, almost. Oh my God, it's only 9:30. You ever think about that? It's 9:30 and we're in our third class. Like, I mean, some people are just getting to work. How crazy is that, right? Anyhow, what you should have noticed over the last couple of days is that it's really a three-part lesson, right? We're really taking 3 days to get through kind of one topic. And what is that one topic? Well, it's evaluating values for sine and cosine, right? It's figuring out what cosine and sine are of certain angle measurements, okay? And so today we're going to continue that conversation, okay? And we're going to talk not only, guys, about these nice angles that keep showing up, angles that have references of 30, 45, and 60, right? So we'll talk about those a little bit more. We'll talk about the quadrantal angles, in other words, the ones that are multiples of 90, right? So we'll talk more about those. And then we'll talk a little bit about, well, what happens if it's not one of these nice angles, like 30, 45, or 60? What do we do then, okay? So we'll look at all those scenarios a little bit today. Guys, what is sine of theta equal to? Equal to the y value. Absolutely. And cosine of theta is equal to the x. All right, so one of the things that I hope you're realizing is that this is one of those topics that, yeah, you do need to spend a little bit of time outside of class just to review these things, right? Because it's kind of a lot of little facts. Jaylani sort of said it. She's like, there's a lot of stuff going on here. And that's true. There are a lot of things going on here. So there's definitely things you want to review. All right, so here's what I want to do, guys. I want to know the value of f of x equals 6 sine of x. And I want the what? I want the exact value, which means no decimals, of 60 degrees. Well, your training suggests that you need to take 60 and plug it in, right? And if you guys are thinking logically, the logical thing to do would be to type it in the calculator, wouldn't it? 6 sine of 60? I wonder if we can actually calculate that. So what I'm going to do is I'm going to go to 6 times sine of 60. Now, if you look at the problem, guys, what is 60 in terms of? You hit the button next to the 7, the trig button. Everybody cool with that? Everybody see it? So it's right here. You click that and you get all your options. Okay. What is 60 in terms of? Degrees, right? So I want to make sure if I hit the pi button now, I want to use the degree symbol, right? A lot of teachers in the past, if you've talked about trig, have talked about the mode that your calculator's in. Where does that sound familiar? Raise your hand if that sounds familiar. You need to be in a particular mode. Yeah, those of you that took geometry know what I'm talking about a little bit. If I put the degree symbol there, it doesn't matter what mode you're in. The calculator will know what you're talking about, okay? So here's what I get. I get 5.19615. 5.19615. And of course, oops, sorry guys. And of course, you look at that answer and you immediately know that it can't be correct because the problem asks that you had no what? No decimals in it. So then the question is, well, what are they looking for, right? What are they looking for? Well, they're looking for the what? They're looking for the sine of 60 answer that we get from that nice chart, right? So let's talk about what that looks like. So here is our unit circle. Where is 60 degrees going to put me? In what quadrant am I going to go? First quadrant. And we know that I need this point, right? Why do I need that point? Because if I can figure out the y value of that point, I know what sine of 60 is, correct? Okay. So what's my reference angle if I'm at 60 degrees? Well, I either keep going forward to 180 or I go back to where I started, which is shorter. Going back to where I started, absolutely. So 60 degrees is my reference angle. All right, as you would say, from the point, let's drop down and create our right angle. And we created a unit circle, right? So this is 1. What's across from the 60? The radical 3 over 2. And across from the 30, which I didn't put the 30 there, but it's obviously the missing angle, is what? 1/2, right? Now, give me directions, guys. How do I get to my blue point? Go right, 1/2, go up, radical 3 over 2, so that's got to be this, right? Because that's the y value. So I know that sine of 60 is equal to positive radical 3 over 2. So what am I going to do? I'm going to say that f of 60 is 6 times, because what did it want me to do, guys? It wanted 6 times sine of 60, right? So I'm going to do 6 times this radical 3 over 2. Guys, what is 6 times something over 2? What happens to the 2 and the 6? Can I reduce those? Yeah, I can, right? Because 2 goes into 6 how many times? 3 times. How do I know if my answer is right? I got 3 radical 3. How do I know if that's correct? What would I do to check it? Jameson, don't I have the answer that the calculator gave me right here? So shouldn't this answer be equivalent to that answer? So if I type in 3 radical 3, I better get what? I better get the same thing that I got here. And I did, right? So it's a good way to check it. Okay. G of little fish guy. That's another symbol. It's called the beta symbol. Okay. So what do I want to do? I want to know what is the value at 330. So I'm going to say, okay, well, G of 330 equals all of that, right? So again, would it be reasonable to want to plug this in my calculator to figure out at least what my answer is as a decimal? Yeah, because then I can check to see if I did it right. So go ahead, guys, type that in and give me a decimal. Make sure that you use the what when you're typing it in. The degree symbol. You gotta have the degree symbol, okay? What do you guys got for a number? Briggs, what do you got? Can somebody read the numbers that are on the calculator to me, please? 4.4641. Does everybody agree with that? That's what you got? Good. Okay. Well, we'll see. We'll see if it's right. What's the matter? You don't like it? What'd you get? Yours is just 3?
No, it's 3 and then it has
Oh,
the
it's
same
3 and then
decimals.
it has the same decimals. Okay, but why? Let me ask you this. Why didn't you just type it as one string? Like why type this and then type this separately? Just type it as one string, right? Because you're supposed, I think what happened is you're supposed to subtract these. I'm not sure that you did. All right, bad news though, guys. I wanted an exact answer, right? So again, I gotta create this diagram. 330 is going to put me into which quadrant? Quadrant 4, okay. Unit circle, 330 degrees. Puts me on this point right here. That's the point I need to get, right? Guys, what do you think? What is my reference angle? I'm at 330, right? Am I going to go all the way back? Or am I going to go forward the little bit that's left? Forward. How many degrees is it to go forward? 30 degrees, because I need to get to what number? 360, okay. All right, so here's my right angle. Okay. Here's my 1. Here's my 1/2. Here's my radical 3/2. So what are the coordinates of my blue point? How do I get there? I move over which way? Right radical 3/2? Okay, so that's the x value. And not negative 1/2 because I had to go down, right? Okay, which of those goes where? Which of these is the cosine and which of these is the sine? Cos is the x, sine is the y, right? So if we actually get the exact value, it's going to be 4 times the cosine value. So this is the cosine value and this is the sine value. What do I get here, guys? How many times does 2 go into 4? Twice. So this is 2 radical 3. And the 2 negatives here make a positive, right? And what is half of 2? 1. So I got 2 radical 3 plus 1, right? Hopefully that's our answer. Hopefully that's our answer. .4641, and that's what we got, right? 4.4641. So this definitely checks. Cool. Why is this a problem that we like a lot? Multiple choice. Okay, I agree. Yeah. What do you notice about all the angles? Multiples of 90. So they're called what kind of angles? Starts with Q. Quadrantal, meaning they're what? On the axes, right? So this is the scenario that I think we decided yesterday, well, 2 days ago, that we liked the most, right? Because if I want to find these values, they're simple. Why are they simple? Because it's either this point at 0 degrees, this point at 90 degrees, this point at 180, this point at 270, and that same point at 360. And is it difficult to label those points? No, because those are what? Just points that are on the unit circle, right? So I know that what? This length is 1, 1, 1, and 1. So how do I get to this point? I go to the right one. Do I go up or down at all? No, so that's the point 1, 0. And what's the point at 90 degrees? 0, 1, yep. And what's the point at 180 degrees? Negative 1, 0. And at 270? 0, negative 1. There you go. It would, yeah, good question. Yeah, Trinity said, well, what if it was negative 180? Then I would go this way and I'd still wind up at the co-terminal spot, right? Yeah. All right, so what do I got to figure out here, guys? Cosine always goes with what? The x value, right? So what is the x value at 0? 1, so this equals 1. Cosine of 360 is the same as cosine of 0, right? These are the same. Sine of 90 puts me here, right? That's this value. That's 1. What is sine of 270? Sine of 270 puts me here, and what's that value? -1. So this is not equal to 1, right? That's a nice, easy one. We like that one. By the way, if that's on a Regents exam, what are you probably going to do? You're probably just going to type them all in, right? Because the calculator will give you all those as well. All right. An angle has a terminal ray that falls in the 3rd quadrant. It is known that cosine equals -0.96. Guys, when I give you that piece of information, aren't I giving you one of the x or y values? Yeah, I'm giving you which value if I tell you cosine? X, right? So I know that on this point, I have an x value of -0.96. What does it want me to find? It wants me to find the value of sine, right? Well, the value of sine is whatever this y value is. So you might look at this and be a little bit nervous. Like, how am I going to figure that out? There's not enough information here. But what happens when I do this? Well, how does that create enough information? Because it's a unit circle, right? So it tells me that that distance has to be 1, correct? Now, if I drop down here and create my right angle, I actually get a really, really important piece of information. What do I know about getting to this point? To get to that point, I have to go left how much? -0.96. Well, doesn't that tell me how long this piece is? Yeah, that's 0.96. And what did I want to find out? I want to find out the y value, right? I want to figure out how far I have to go down. So hang on. What did I just give you? I know I have to go down. So I know that the y value has to be negative. So what 2 choices can I get rid of? 3 and 4, the 2 positive ones. Now think like a teacher for a minute, guys. I want you to think like a teacher. Knowing that my choices is one of these 2, right? Which one of these is probably the answer based on the choices that we crossed out? Think about it. Think like a teacher. Think like a teacher. So you're sitting here, you're doing this problem, and you use what to get the value of y? Pythagorean theorem, right? Now, guys, the Pythagorean theorem is going to give you the length of a side, correct? Can the length of a side ever be a negative value? No, so when you actually evaluate this, we know the value of y is guaranteed to be what? Positive. But we know that the answer to the problem can't be positive because to get there, we had to go down. So which one of these do you think is going to be the answer? Choice 1. Because look at this choice right here. It's the same number, right? This is what's called the distractor, right? This is the positive answer that we're probably going to get for y. That's the one that the student who sort of rushes and doesn't think about it gets. But the right answer is what? The negative version of that, okay? So that's just a little test-taking strategy there, right? Anyways, if we did the Pythagorean theorem, we would have 0.96 squared plus y squared equals 1 squared. And when we solve that, we would get 0.28. But of course, we know that's not the right answer because it had to be a negative 0.28. Cool? All right. For the inquiring minds in the room, I talked a few minutes ago about degree mode and changing the mode of the calculator, right? This is how you do it. Quite frankly, guys, ignore this. Okay, I don't care if you're in degree mode because you're always going to put what on the number. the degree symbol, which means it doesn't matter what mode we are in. All right, down below. Here's where I'm going to start talking a little bit about some weird scenarios that could happen. Okay, what I'm going to do is I'm going to put all of these in the calculator for a minute. And I want you to notice what happens. All right, so what do we have here? We have sine of 110. I know you guys can't see that. That's stupid. That's a little better. All right, so sine of 110 degrees. All right, so I get this, right? Sine of 70 degrees. And I get this. What? Same answer? Okay. Cosine of 110. And cosine of 70 degrees. What? What do you notice here? Well, these two answers gave me the same thing. These two gave me things that are really, really close to one another, except one's positive and one's negative. So let's talk about why this happened, okay? Super, super important, okay? If I go back here for a minute. $70 degrees is right here, correct? What's the reference angle of 70 degrees? 70 degrees because I'm going to go what? I'm going to go back, right? Okay, 110 degrees. Where's 110 degrees going to put me? In which quadrant? Quadrant 2. That's 110 degrees, right? What's my reference angle here? 70, because I need to get to what? I need to get to the 180, right? So what do you notice? The reference angles are what? Exactly the same. Well, if the reference angles are exactly the same, when I created my pictures, I'd have the same picture, wouldn't I? What's the only difference? Some are positive, some are negative. Well, what determines whether or not something is positive or negative? All students take classes. All students take classes. So check it out. In this scenario, guys, sine for both of these gave me the same value, right? Well, let's talk about why. What is the value of sine in the first quadrant, positive or negative? Positive, because what's positive in the first quadrant? Everything. Now, what about sine in the second quadrant? It's still positive, which is why we got the same answer for both of these. In the first quadrant, what is cosine? Positive. In the second quadrant, what is cosine? Negative, which is why these two gave me what? The same answer, except one being positive and one being negative. Makes sense, right? So if I have the same reference angle, guys, what's going to happen? I'm going to get the same answer, except in some instances it might be negative. And in some instances it might be positive. It all depends on which quadrant we're in, correct? Okay, cool. I'm going to bypass this, okay? It would just show us the same thing. All right, so what we're going to do is we're going to take that concept, practice that concept, and then we're done. Okay? That concept of using reference angles to help us do these problems. Okay? So I don't want to draw diagrams here. Okay? I don't want to draw diagrams. All I want to do is use these facts up above, this fact in yellow, and this fact in blue. Right? And what I'm going to do is I'm not going to draw a diagram, but I am going to create a quick sketch just to make sure I get the right reference angle. So 150 degrees puts me there, right? For example A. What is my reference angle for example A? 30 degrees, very good. All right, so I have my reference angle of 30 degrees. So here's what I want you guys to think about. Ready? I just said a minute ago that what? If I have a reference angle, it's the same regardless of quadrant, some being positive, some being negative. Fair to say? So is it fair to say then that cosine of 150 is equal to some value of cosine of 30? The only thing I got to figure out is that cosine of 30 positive or negative? Well, I'm in quadrant number 2. And what is the value of cosine in quadrant number 2? Negative. So cosine of 150 is equal to negative cosine of 30. And up above, I gave you cosine of 30, didn't I? So this is equal to negative radical 3 over 2. So what did I do right there, guys? I did two things. Thing number one, I determined my reference angle. Thing number two, I determined my sine based on the quadrant. Sine of 150. Guys, sine of 150 gives me the exact same reference angle, right? Okay, so the reference angle is still 30 degrees. So sine of 150 is equal to some value of sine of 30. The question is that value positive or negative? Well, what is sine in the second quadrant? Positive. And what is sine of 30 based on the blue up top? 1/2. Cosine of 210. Okay, so let's create a quick sketch just so we know if we're in the right spot or not. 210 puts me into which quadrant? Quadrant number 3, right? All students take classes. Okay, so which quadrant am I in? Quadrant 3, right? Quick question, what is my reference angle? If I'm at 210, do I want to go to 360 or back to 180? Back to 180, how far is it? 30 degrees. So I have a reference angle equal to 30 degrees. So cosine of 210 is equal to cosine of 30 degrees is cosine positive or negative in this quadrant? Negative, because what's only positive? Tangent. Negative cosine of 30 is negative radical 3 over 2. Blake, I'm going to give you guys 5 minutes. And what I want you to do in the next 5 minutes is take a look at the 6 examples below. Hey guys, how are you going to do these 3? You're going to change them from radians to degrees. And how do we do that again? Change pi to equal 180. Good. Okay, take 5, 6 minutes and give me the values for those 6. All right, guys, I got a bunch of them up here. Ready? Those last three, if you sat there and redid them, that was kind of silly, right? If you created the degree equivalent, then if you just look back, you had the right answers there. Again, the key to these guys, make sure that you're looking at the what? Make sure you're looking at the sine, right? You got to have the right sine. If you can get the right reference angle, that's half the battle, but then picking the right quadrant and the right sine is the other half, right? Trinity, how'd you do with these, okay? Oh, girl. Good job. With C? This one? Oh, wait. This one. Okay, so did you convert it? Okay, so when you did 180 divided by 6, you got 90? Cool. What'd you do? Divide by 2? Yeah. Briggs? When to put the negative. Okay, so all you need to do, right? All you need to do for this is simply this. If you're 210, you're in the third quadrant, right? So the only thing that's positive is tangent. If I'm 330, I'm in the fourth quadrant. So the only thing that's positive is cosine. So this one's positive. If I'm 330, I'm in this fourth quadrant again, right? Well, if the only thing that's positive is cosine, then sine must have been, right? So I'm just figuring out which quadrant I'm in. If the letter matches, it's positive. If the letter doesn't match, it's negative, except for the first quadrant, right? Because the first quadrant, everything's positive. Other questions, guys? Anything else? I think that is it for today. All right. What do I have, guys? I have for you the first 3 assignments, 8-1, 8-2, 8-3, are going to be due for you guys on Monday. Okay. The first 3 assignments. Now you can actually get started on the 4th one because we've already done most of that. Okay. Cool? Happy? Me too. Yeah.